as it is on line 4. Okay, now this part is important because we don't want to specify 2 question marks in the return info cell. If you specify 2 question marks, then the question is, when you specify the return value, which one are you going to replace with the return value? You can only replace one thing at a time. Okay, so that's why this time we have the first or the left-hand side being replaced by a single question mark, which signifies that that is the subroutine that we are calling. We're handling that one first. Okay. The other one, since we're not taking care of it yet, we just leave it the same way as we find it in the original code. Then we get into the subroutine on line 2. We copy and paste the return info cell, and we are returning a constant value of 8, which means we take the question mark out, we replace it with the constant value 8, and we are done with the return statement. Then we go to line 3. Line 3 is going to deallocate this entire column, and then we continue execution on line 4. Are we doing okay so far? Okay. In other words, so far we have not changed the mechanism of returning a value. We're still doing exactly the same thing as last time, except we have to do it again this time. Because now that I'm back on line 4 doesn't look like the original code anymore, because the first invocation on the left-hand side is already resolved to a constant of 8. But I'm not done yet. I cannot print the value yet, because I still have the right-hand side to resolve. In other words, line 4 now looks exactly like this. In other words, we have another invoke to take care of this time. So that's why when we're back on line 4, we have to handle the second invoke of the same subroutine. Now, it is true that it is going to do exactly the same thing. It's going to return the constant of 8 again, but we cannot optimize it out. Okay? And when you have 2 invocations, you have to invoke in both cases. You cannot say, oh, since we know what the first invocation is going to return, the same thing is going to happen to the second one. It doesn't work that way. Okay? So in this case, we already handled the first one, so we keep whatever is already resolved. But now we are going to invoke the second one on the right-hand side. So that one, it is its turn to be turned into a question mark, because now we are trying to resolve what it is supposed to be. And then we go into the subroutine again on line 2. Line 2 is going to replace the question mark with whatever is returning. So this time we replace the second part of the addition with an 8. And then we go to line 3. Line 3 is going to deallocate whatever we have allocated at this point, and then we get back to line 4. This time, when we get back to line 4 now looks like this. Print 8 plus 8. Are there any invocations that we need at this point? Do we know how to calculate 8 plus 8? It's 16. So as a result, we can execute line 4 at this point. It will just print the value of 16, and we are done. Are there any questions about this particular one? Yep.
What's the calculations?
Sorry?
What's the calculations in the subroutine where you put?
Then it depends on, by the time you execute the return statement, the expression to the right-hand side, what value is it specifying?
Well, but if you're tracing it and say there was line 3 was a bunch of calculations or something.
Mm-hmm.
So when you do the trace
You mean line 2?
Oh yeah, line 2,
Mm-hmm.
a bunch of calculations and then it returns whatever it is.
Mm-hmm.
Then for trace of line 3 in the parentheses, would you put what it is after that?
That's a good question. Let's handle that case. Okay, I think your question kind of prompts me to kind of move the schedule a little bit ahead of time so we can actually talk about factorial again. You guys do remember factorial? The same program that we have been using to illustrate various concepts of calling subroutines. So let's go ahead and make sure we save this one first and make sure that we don't have any additional questions about this one. Okay, so we'll say 2 invokes on one line. Okay. Are there any questions about this particular one first? Because if we have questions about this one, we won't be ready for the next one. No questions? This is all good? Okay. Let's go ahead and look at basically the last reincarnation of factorial, because this is the best way of implementing factorial as a recursive subroutine. So we'll go define sub-factorial, and it only requires one single parameter that is passed by value, which is n. Then we can say if n is less than or equal to 1, then return 1. In other words, if n is 0 or 1, then n factorial is a constant of 1. Okay, that's pretty much by the definition of factorial. Else, which means n is greater than 1, it is 2, 3, and so on. Now, this part is going to be kind of interesting because we will return n times invoke factorial. This time we use n minus 1 to specify the new parameter n. Right. And if n define sub. Okay, this is the shortest implementation of factorial implemented as a recursive subroutine. Okay, but from our perspective, it can also be kind of confusing because it is combining many concepts that we have seen so far together. Let's just talk a little bit about the construct itself. The biggest problem is line 6. Okay, because line 6 is doing two things at the same time, and those two things, will basically cause major confusion, if we don't, follow the mechanism, step by step and clearly. Because the first thing it has to do is to invoke factorial again. Okay, so that invocation of factorial will at some point return. Okay, at some point that invocation will return a value. That value will take the place of the invoked part of this statement, which basically becomes a number. I multiply that number to n, which is a by-val parameter. That will generate a product. That product, in return, will be used to replace the question mark in the return info cell. Okay, but the problem is, if we do this within if we do 3 factorial, the statement that contains the question mark is another return statement. And that's why it will look kind of confusing. So we'll go ahead and take a look at this one. We invoke factorial, and we'll just go ahead and figure out what is 3 factorial. This is basically the same thing, the same logic that we have been doing. We have been trying to figure out what is 3 factorial for a while. Obviously, we should know by now it's in terms of value, it is just 6. But the mechanism of figuring out 3 factorial is changing over time. The first time we did it, we used global variables. The second time, we made use of local variables. The third time, we made use of by-val parameters. The fourth time we did it, we used by-val and by-ref parameters, and we got rid of global variables altogether the fourth time. And this is the 5th time. The 5th time is even better because I don't even have a by-ref parameter to pass the result of the factorial out again, because the value can be consumed right away, and in this case, I'm just printing it out. Okay. So let's go ahead and see what this trace will look like, because it's going to be kind of ugly. Well, in a way. It is also kind of nice in a way because it is actually very elegant. Okay, we have comments, we have line number. The precondition, once again, has nothing to specify because I don't have a single global variable in this entire program. And we start with line 9, which is the only line outside of the definition of a subroutine. Line 9 is a print statement. But in order to know what to print, I have to somehow resolve, invoke factorial first. In other words, I have to invoke, the factorial before I can print. That means, it is almost the same thing as before. We have return info, and we just copy in line 9 almost entirely. except we replace the invocation with a single question mark. Yep.
Whenever we see print in something like this, is it automatically the first line we go to, the first thing we initiate?
Say it again.
I notice like every time there's a print in the trace, then that's the first thing you always implement. It's the first thing.
Well, this is a sample program. I just want to make it as simple as possible. It doesn't have the print statement. I can actually make this, I can make invoke factorial to be on the right-hand side of an assignment statement so that a global variable gets updated by that value. I can even use the result of invoke factorial 3 to pass it on as a parameter to another subroutine. Yeah, we should do it next.
Oh, no.
Use the result of one invocation to specify a parameter of another invocation. Okay, it sounds really awful. It sounds really bad. But if you think about it, it's not really that bad because it just follows the same order as what you think you should follow to get it done. Okay, so we'll deal with this one first. We're invoking factorial. We set up return info, but there's also one more thing to set up because factorial does have a by-val parameter n. So now we have to set up n. What should we put here? What is the value of 3 as a by-val parameter the first time we invoke the subroutine? 3, right? I mean, because it's kind of spelled out here. Okay, so n, parameter n has a value of 3 initially. That's it. That's how we set up, the 2 columns for the first invocation of factorial. So now that we have set up where to go back to and all the parameters and local variables, which we don't have any in this case, we can go into the subroutine. The first action of the subroutine is on line 3. It is the first line of a conditional statement. On line 3, we evaluate pretty much the only condition we have to evaluate for this entire program, which is checking whether n is less than or equal to 1. Is it? No. Nope. Okay, so it is false, which means we have to go to the else branch. The else branch is on line 6. And on line 6, it looks kind of confusing, but I don't really care about the rest of the statement. It contains invoke factorial, which means I have to first get it resolved first. Okay? It can be a print statement, can be a return statement, can be an assignment statement. I don't really care because I cannot do anything else until I have resolved what is the result of the invoke factorial. So that's the first thing I want to do. In order to invoke factorial, I have to set up the same 2 columns. I have to allocate 2 additional columns, one to remember the return info and one to remember, one to set up parameter n. What should we put in the return info? Remember what I said? You copy and paste pretty much the entire line except the invocation that you're taking care of at this point gets replaced by a single question mark. So that means we copied the entire line 6. Return n times, but this part is the invocation. So that part gets replaced by a question mark. Are we doing okay so far with how we set up the return info on column E and row 7? Sort of? Okay. Now what do we use to specify n? That's the other part that kind of looks confusing, but it should not be. Okay, we're looking at this part of the invocation. We are using n minus 1 to specify n. So at first glance, it may look like a chicken and egg problem. Okay? How can I specify n, using n itself? But you have to remember, we are not using the same n. The left-hand side of the right arrow specifies the context that we already know. In other words, the n of the n minus 1, this part here, refers to which column? Column D. Does column D have a specific